Hi, thank you for coming by my poster. It's entitled Recent Enhancements to the CyberShake PSHA Platform. And so I'm focusing on two major updates to CyberShake in the past year. One is a new CyberShake study in Southern California, and the other is the release of a CyberShake data access tool. Let's talk about the study first. So this is a new broadband CyberShake study in Southern California that combines deterministic low-frequency results with stochastic high-frequency calculations performed using SCEC broadband platform modules. 1 second is our frequency where the two merge. And so this is in some sense an update of the CyberShake study that we did in Southern California 7 years ago with two big changes. One is updates to the velocity model, and the other is updates to the rupture generator. With the velocity model, one of the things that we noticed is that the velocity model has very high VS values outside of the basins. You can see that in this plot here, these values that are as high as 2,400 meters per second at the surface. And so what we did is we applied a VS30 based taper to the top 700 meters outside of the basins to help us reduce those near surface velocity values. So our approach was to query with the starting model, CVMS 426M01. This blue trace here is the VS profile. You can see it's very high at the surface. We then performed the same query, but for the top 700 meters, we use an Ely Jordan VS30 based taper. And so you can see in this example, right, they match at 700 meters because it's a 700 meter taper, but we have much lower VS values leading up to the surface. And then what we do is at each grid point in the mesh, we select whichever approach gives us the lowest VS30 values, and we use that. So that way we preserve the basin information where we have it, but outside the basins, we use the taper. And you can see the impact here at the surface. We bring down the velocities outside of the basins a great deal. At a depth of 300 meters, we still have, lower velocities, but, not as much. You can see that the basins are still lighting up, which is what we want, right? We want to preserve kind of those basins and those basin effects, but bring down the near surface velocities elsewhere. The other major change was changes to the rupture generator. So we now use the same version of the Graves and Pitarka rupture generator as is used in the most recent release of the SCEC broadband platform. There are some sample plots comparing the old rupture generator on the top to the new one on the bottom. Overall, what we see is we have reduced slip rise time correlation. We have reduced shallow rupture speed, slightly weaker directivity effects, and a little more energy at 2 to 3 second periods. The other things that we've changed when it comes to the ruptures is we now allow the rupture velocity to vary. Instead of being fixed at 80% of shear wave velocity, we sample variability there as well. And we've reduced our hypocentral spacing from 4.5 to 4 kilometers. So this increases the number of rupture variations we have and increases our sampling. Just to show you a couple of the resulting hazard maps. Here on the left are our low frequency hazard maps from study 2212. In the center is a ratio of hazard maps from this study to the last big study in Southern California. You can see that at 10 seconds, the overall trend is that the new results are a touch lower. At 2 seconds, we see that the new results are higher outside of the basins, and that we believe is due to the changes we made in the velocity model. If you compare the new results to ground motion models, you'll see that at 2 seconds, overall they're largely lower. At 10 seconds, we see that they're higher in the basins and lower elsewhere, probably due to either basin effects or basin directivity coupling effects that we see there. The other major update to CyberShake that I want to discuss is the release of the CyberShake data access tool. So in the past, it's been difficult for users to access CyberShake data. It involves emailing me if you want seismograms or running database queries if you want other data and metadata. So we developed this pure Python command line tool where users can request a certain data type, apply certain filters to get just a subset of the data, and then the data is pulled over the internet down so you get a local copy. We've used this tool to expose all the data that's available in study 2212, and that includes things like site metadata, event metadata, what's the hypocenter, what's the source name, what's the magnitude, intensity measures, ROT50 at 19 periods, PGA and PGV, and 2-component velocity seismograms. So if you're interested in trying that out, we have a user guide and a tutorial. Here's a QR code for you and a link at the bottom. Thank you very much for coming by. Let me know if you have any additional questions.